Today I'm going to do a test to see how much power this inverter will draw when the battery is at its fully charged voltage. Now we haven't had enough sun yet to actually get the inverter drawing full power and the battery being able to be fully charged at the same time, so I'm going to plug this in. What this is here is actually a lithium ion battery, two of them in parallel, which I charged off the solar earlier on today. They are at 40.51 volts, and I'm just going to discharge them into the solar charge controller. So there's going to be quite a heck of a power getting dissipated here. And when I connect this, it should do wake up, which it does now. And it's going to start drawing a heck of a lot of power from this battery. There we go, and that's it, drawing about a kilowatt. It's going down to about, it's going down now, the input power, because that's it, able to keep the battery at the full voltage. So I'm just going to keep that on while the grid tie inverter ramps up its power. I'm going to see how far it ramps up to. So the grid tie inverter is just connected to my deep cycle batteries, and that's showing the voltage, and that is showing how much power and DC amps the inverter is taking. Now what I find unusual is that it seems to have stabilised about, oh that's strange, it's just shut up, and it doesn't usually do that. Basically what I'm trying to do is just find out where it will stop. This is just like a test for summer, and the reason I've got the voltage up so high is because the temperature of the batteries is only like 10 volts, but as it starts getting hotter and hotter in here, I'll adjust the voltage set point on this a bit lower. It's just temperature compensation, but it seems to be acting a little bit unusually. As long as it doesn't go too near 30 amps, that's okay, because 30 amps is the maximum input current for this inverter. And that fan there is just to keep the thing cool, because it's going to be sitting in a hot shed running it close to full power, so it's going to need all the cooling it can get. Out of the inverter is actually 628 watts, and it's only 600 watts. So although the input current is within spec, the output current or the output power is a little bit too high. But it seems to me that it's going to be okay just to leave it like this. I reckon if I turn the voltage set point down, that should draw a little bit less power, but it seems to be okay. Now what I'm going to do is press the button to switch the inverter off. And it kept control of that really quite well. The voltage never shot up very much at all. Unlike my PowerLab charger, when I'm charging a lead acid battery and I take a load off it, its voltage could shoot up quite high and then it gives an error, but this solar charge controller, it really does control it quite well. And the battery's bubbling away. The battery's at 9 degrees Celsius, so it should really be at 30.5, but I'll always put it just a little bit less. So the first test I done, the inverter was already on to start with. So basically, this controller would have switched the AC side of the inverter on when the voltage of the battery initially rise from about, I can't remember, 25.6 it might have been at. And then I obviously plugged in the bike batteries and it rose from there, but this time I turned it on when the battery was at the fully charged voltage, just to see if that makes a difference. So it appears to stabilise at about 22 amps every time. I can't really see its input current going any more, and at that voltage, the input voltage being 30.25, the output power is 622 watts. So it should be safe enough with that extra fan cooling. It should prevent the output MOSFETs from overheating, because output MOSFETs are actually on this side. I think there's MOSFETs and diodes on this side, and on this side are DC MOSFETs. I'm not exactly sure, but the AC MOSFETs are definitely on this side anyway. And as long as the DC side current doesn't get too close to 30 amps, it should be okay. It's just the output MOSFETs that are probably not going to take it, and the transformers might overheat as well. But by that time, when we're getting the stronger sunshine, I'll have the voltage turned down to probably 29.9. In fact, I'll do that just now and I'll see what it does. Put the absorbing voltage down to, let's just pretend it gets really hot in here in summer, 25 degrees, so I'll put it down to 29.6. So we're pretending it's really hot in summer, and well, turning it down doesn't really seem to have done that much really. Although it has taken the output power down, the input current remains pretty much unchanged. So that'll take a bit of the stress off the AC MOSFETs. We'll just have a look at how hot it's getting. Yeah, it's not too bad at all. Well, it seems that this inverter is quite at home on a 24 volt battery bank. I don't know how it would perform on a 12 volt system. You'd probably get a lot less power out of it. That's a test I can do some other day. But it seems to be okay. And all I'm going to do now is just discharge these two batteries here down to their storage voltage, so that'll be 38 volts. That's 1.1 kilowatt hours that we've got here, well, in theory anyway.